Good afternoon. Today we discuss these TPM activities or TPM in world-class manufacturing. What are the role of the TPMs? Okay, in that TPMs today we discuss the pillars of the TPM. First of all of you know these 5S is the foundation for the TPM, or all the pillars, or total 8 pillars are there. The foundation of these 8 pillars are the 5 years. Now today we consider the one pillars called as equipment and process improvements. Okay, so what are the objectives for these pillars? This is one of the major or important pillars of the TPM activities. Okay, what are the objectives? They maximize efficiency by eliminating waste and manufacturing losses. Okay, these are the major objectives of these pillars. Okay, manufacturing losses are categorized into the 13 big losses. All of you know these manufacturing eliminating of the waste. This elimination of the waste is called as the lean manufacturing. Okay, this elimination of the waste generally called as the 7 waste. These are described by these Shizuo Shingos, the Japanese engineers, industry engineers. Okay, and now this Dr. Shizuo Shingo directly gives the how to overcome this elimination of the waste. Okay, now today we consider these manufacturing losses. What are the manufacturing losses? There are those 13 big losses. These 13 big losses comes under the three major categories. First is called as the equipment losses. Generally these equipment losses consist of these 6 categories, 6 losses. Then come to the manpower losses. Generally these manpower losses include these 4 losses. And third category is the material losses. These material losses are the 3 different types of losses. So total is called as the 13 big losses for the manufacturings. Okay, now first first we discuss the equipment losses. Okay, there are the 6 different losses comes under this equipment losses. Okay, again we can categorize these 6 losses in 3 different losses, which are very most important when you calculate this overall equipment effectiveness for the TPMs. Okay, first is called as the downtime loss, second is called as the speed loss, third is called as the cord loss, because 3 losses comes under this OEE. How to come under the OEs? Because these downtime loss are considered in availability of the machines or equipments. Then speed loss consider these performance of these machines or equipments, and quality loss for the given quality products. Okay, what are the downtime losses? Here today we shortly discuss about the losses or equipment losses. Equipment failures and breakdowns comes under the breakdown loss, downtime loss, and setup and adjustment also comes under the downtime losses. Okay, the setups and adjustment are the part for the downtime losses. So you can calculate this availability of the machines on the base of the failure and the breakdowns of the equipment and the setup and adjustments for the machines. Okay, now second is the minor stopping on idling and reduce the speeds are the speed losses. The minor stoppings, short stoppings due to the unavailability of the materials or unavailability of any resources, and reduce the speeds. So it is called as the higher the cycle times. You can reduce the speed for the production. You can reduce the performance of the equipments. Okay, and next is called as the process errors and rework and scraps. This generally affect the quality of the component, quality of the given product which are given to the customer. The most important. So this total comes under the OE. Now next is called as the manpower or material losses. Manpower losses consist of the 4 losses. This is generally called as cleaning, wetting instructions, wetting quality confirmations are comes under the manpower losses, and 3 losses comes under the material losses called as material yield, energy loss, and consumer material losses. Okay, so our today's aim is to calculate the OE for the equipments. Okay, so overall equipment effectiveness. Yes, it is called as the overall equipment effectiveness, not called as the efficiency. You can calculate the effectiveness of the machines or equipment. So OE figures are determined by combining of the availability of the machines, performance of the machines, and with the quality of the parts to be produced. Okay, so three factors or three measures, three measures part are important. Okay, it's called as availability, performance of the equipment, quality of the parts to be made. So the OE generally the product of this availability, performance, and the quality of the parts. Okay, so OE measures the efficiency of the machines during planned loading time. Then planned downtime does not affect the OE figures here. So you can calculate the availabilities, performance, and quality. So planned downtime is not considered. This planned downtime is not considered for the OE. Not considered means it not affect, because you can omit this planned downtime for the machines. So you can calculate the OE. So how to calculate this OE? Simple formula for the OE is the product of the availability, productions, performance, and quality. So this product is called as the overall equipment efficiency. But how to calculate the availability? Availability is not directly given or not directly find out the availability. So this is called as availability. You can take directly availability for the machines and calculate the OE. So availability consists of the different factors. Okay. So availability is a proportion of time machine is actually available out of time it should be available. Okay, generally mtbf minus mttr, mean time between failure minus mean time to repairs upon mean time between failures. So you can calculate the availability on the maintenance point of views. Okay, now next is the how to calculate the actual, what are the three different losses. This called as the losses. Here we discuss in last slides is called as the equipment losses, downtime loss, speed loss, and quality loss. These losses are reflected on OE. Okay, this availability comes under availability including the downtime losses, performance including the speed losses, quality yield including the quality losses. We can reducing these losses, then we can increase the OE. Okay, our target for the OE is near about the more than 85 to 90%, more than 95% is required for the TPM environments. Okay, so you can reduce these losses, we can eliminate these losses, we can take actions against these losses. What is the actions given when we action plan for the downtime loss? Then we increase the availabilities. When we work on the speed losses or to increase the cycle time, reduce the cycle time, at that times we can increase the performance. When we reduce the quality or rejections or the scraps or rework activity, then we increase the quality yields. So we can ultimately increase the overall equipment effectiveness. Okay, now what are the formulas for this calculating this OE? Okay, availability is equal to time available for production minus downtime upon time available for productions. This find out the availability. Then how to find out the performance is the ideal cycle time into number of parts to be produced upon the operating times, and quality yield is generally equal to total number of parts produced minus defect numbers upon total number of part produced. So you can find out the quality, then product of this all is called as the OE. Okay, now this slide shows some TPM measurements. What are the measurements required to calculate the OE? Okay, OE is called as the availability, performance, and the quality. Then how to find out this planned availability is available time minus the planned downtime upon the available times. Then performance, you can find out the performance by using the idle cycle time into the output upon the operating time. And how to calculate the quality rates is quality rate is equal to output minus rejections of the products divided by the total output of the components. Okay, just this is the short measurements which are required for calculating the OE. Okay, so now take a example how to calculate the OE, how to find out this OE. Okay, is an example consider of the single press in a plant for 1 week operations. When we perform when we run the one press for 1 week, then we find out the OE for these equipments. Okay, so these are some given data. The operating schedule is equal to 120 hours per week. Non-operating time is 250 minutes per week. Maintenance downtime is equal to 500 per minute per week. Change your time downtime is equal to 4140 minutes per week. Then total output of the components is near about the 15,906 pieces. This is again the per week. Then ideal production rate is given 9.2 pieces per minute. Then rejected pieces is 558 for a given week. Here only the operating schedule is given is 120 hours per week. This is the schedules. Okay, this is the available times for these machines. Okay, here about this is 120 hours per week, so we can convert these hours into the minutes. Okay, now you show here them how to calculate the OE. Then some start we find out the plant availability. What are the availability? Is available time minus a plant downtime divided by the available times. Okay, available times is equal to 120 hours per week is given, so we can convert this hours into the minutes. Is near about the 7,200 minutes. Then we can find out the plant downtimes which are required to calculate the availability of the or plant availability. Okay, so our plant downtimes generally we take these three parts near about these non-operating times, maintenance downtime, and changeover time. These are the major plant downtimes. 250 plus 500 plus 4140 minutes is okay, so we can calculate the plant availability is equal to 0.32. This is the rate of the plant availabilities. Then operating times, performance rate, ideal cycle time into output upon operating time. So you can first calculate the operating times. How to calculate the operating times is near about the available time minus total downtimes. Okay, what is the available times? Available time is given is near about this 7,200 minutes is given. Then total downtime, this total downtime is nothing but is 250 plus 500 plus 4,140 is given, so operating time is near about the 2,310 minutes is calculated available times. So we can find out this performance. So performance is equal to 1 upon 9.2 pieces per minute. This is called as ideal cycle times into the 15,909.906. okay, divided by the operating times. What is operating time? Is near about the 2,310 minutes. So the performance is near about the 75% for the given one press of the organizations. So you can calculate the quality. How to calculate the quality? Quality is nothing but the output minus rejection upon outputs. What is the output? Is near the 15,906 minus 558 is the rejected components. Okay, so you can calculate this quality is near about the 0.96. So multiplication of all these factors 0.32, 0.75 and 0.96 is near about 0.23 is equal to 23%. This is called as the overall equipment efficiency is 23%. But what are the evaluations from this? Is 23% is okay or not okay? Absolutely it is not okay. We required, what are the target for the TPM? TPM target in near about the more than 85 to 90%. Okay, so how can we can improve this OE? So for improving this OE, we take the different steps or different actions against the productions. Okay, then what are the factors, what are the components we can take actions? Okay, first reduce the downtimes. Major component is called reduce the downtimes. Then reduce the number of rejections, so we can increase the quality. then increase the production rates. So we can increase the production rate, we can increase the performance of the machines. So three factor again important things. First is called as availability. How to availability is increasing? By decreasing the downtime losses. How to increasing the quality? Decreasing the rejections. So we can increase the qualities. And what are the increasing of the performance? By increasing the production rate. So we can reduce the cycle time, we can reduce increasing the production rate. So we take some quantity, some figure for this. Reduce the downtime losses is near 695 minutes per week. Then number of reactor component 5582 5645 per week, and increase the production rate is near about the 54516 pieces per week. Okay, then we calculate the OE. Okay, so for this calculation we can find out this OE near about the 81. From 23% to 81% we can increase the OE on the base of to find out these, or we can take actions on only these three factors. Okay, so it is a very important factor. You can reduce the downtime losses, we can increase the production rate, we can reduce the rejections. So we work on only three factors, we can change this 23 to 81%. This is a short example for the overall equipment effectiveness. Okay, thank you.